All right, it looks okay. Now, before I try to unzip this, let me go to my Hack the Box panel to show you the challenge, what we are up against. Before that, it looks okay. Fine. Now I go to Sherlock's. So it's a retired Sherlock. So we are allowed to create a write up, publish it only on the Hack the Box retired content. So this is their policy. Interceptor. Yeah. So the category is easy. Let's read through this scenario. A recent anomaly has been detected in our network traffic, suggesting a potential breach. Our team suspects that an unauthorized entity has infiltrated our systems and accessed confidential company data. Your mission is to unravel this mystery, understand the breach, and determine the extent of the compromised data. So looks like a potential intruder, and we are given a packet capture file. So all we need to do is to investigate this incident and try to answer the questions that we've been asked. Okay, so this is the file. I've already downloaded it. Let me copy this file, the zip file's password. Better I open a tmux session so that I can create multiple windows same time. I named maybe intercept. Yep. All right. Now what I can do, let me unzip this 7zx. Come on. Interceptor.zip. The password will be HackTheBox, which is in my clipboard. All right. Now we got the pcap file. So let me see the pcap file now. It says packet capture file microsecond TS Little Indian version 2.4. Ethernet capture and 65535. All right. Okay, I guess this 65535 denotes the number of ports. All right. Anyway, let's see the scenario. What's the IP address did the original suspicious traffic comes from? An attacker downloaded a suspicious file. What is the HTTP method used to retrieve the properties of the file? Okay, you're directly seeing the answer because I already solved this challenge. I don't want to show you the answer so that we'll be keeping that thrill alive. All right. Let me do one thing. I need to copy a few more files. I go to this Sherlock's directory, SOC, Interceptor. I need to copy the file questions here because the file's questions is actually having the questions, the list of questions that we are asked. All right. Let me open a text editor to read through these questions. So these are all the questions we are asked. What is the IP address the original suspicious traffic comes from? The second question, the attacker downloaded suspicious file. What is the HTTP method used to retrieve the properties of this file? It appears that this file is malware. What is its file name? And what is the deep hash of the malware as reported by VirusTotal? Okay, and some questions about Niki analytics community, some VirusTotal related questions, and what is the creation time of the malware, and what is the domain name the malware trying to connect, the IP address the attacker has constantly used for the communication. All right, looks like this packet capture has some malware in it, but we are going to uncover it soon. What is the program used to execute the malware? What is the host name of the compromised machine? The key that was used in the attack? What is the OS version of the compromised machine? All right, a lot of things to answer. But before that, when you are up against a pcap file, you must know where to start all these things. So let me see the pcap file. 1 second. I'm planning to open my notes, and I'm not going to show my notes to you. So it's completely to me for my reference. And give me a sec. Come on. Just trying to keep my notes this side. Okay, so let me refer my notes for a while. Come on. Where is the Sherlock? Forensics Sherlock. Yeah, I got the notes. All right. Okay. Now I use the stat command against this pcap file, and you can see some information about the file. You could see the date here, where the modified date. The remaining dates, it points today, but this particular date stands unique because I guess this is when the file created, but I'm not positive. We're going to find that quite soon. And you can see the size of the file. Apart from that, nothing special. Then moving on, I have another utility called cap infos to read some information about this pcap file. So it's gonna give me some metadata about the pcap file, and you could see the name of the file, the number of packets it has, the file size, the capture duration, how long the packet capture was. It was captured. The packets were captured. It was captured for 5 or 6 seconds. And you can see the first packet time and the last packet time. As I said, this particular date stood unique because this is when the traffic got recorded. And some hash, the file hashes, looks cool. Apart from that, do I have any other useful stuff? Packet size limit 65535 bytes. Okay, fine. Now we have seen some metadata. Now straight away, let's go and see the packet capture by using Wireshark. Okay, how about that? How does it sound like? Wireshark interceptor.pcap. All right, cool. Now we just opened the Wireshark capture. Now what I'm going to do, the first thing I always do once I opened Wireshark is to see statistics, because this is where you could see the overview of any packet capture file. And this one is the file detail. This is what we just witnessed by using the tool called cap infos, right? But now this one again shows the same. The first packet captured, second packet, and the elapsed time. So it has all these things, and you could see the number of packets this particular capture file holds. Okay, so this is what it is. And I'll close this metadata, go again to the statistics, resolved addresses. Do I see any useful stuff here? Nope. I could see some hardware address, a MAC address, then some names in it. A lot of names, to be frank. All right. So it has a bunch of hardware addresses. That's okay. Moving on, protocol hierarchy. I found this option is quite useful because it will be giving you an insight about the protocol hierarchy, the protocol structure from the wire to application layer protocol. Okay, so let's see what we have. The frame Ethernet and all not going to help us, but from IPv4 you could see we are having some UDP traffic and some TCP traffic, transport layer uh, protocols, TCP and UDP. Then the UDP has a protocol called Simple Service Discovery Protocol. So let's search what it is. Simple Service Discovery Protocol. Mean is a network protocol based on the Internet Protocol suite for advertisement and discovery of network services and presence information. All right, so it is associated with Internet Protocol, the IPs. Fine. Then NetBIOS datagram service. It has SMB. So we could see some server message block, some SMB traffic. Then Microsoft Windows browser protocol. Let's see what it is. I'm just trying to understand that protocol hierarchy completely. Microsoft Windows browser protocol. Means browser service, computer browser service is a feature, or common internet file system browser makes the following possible service. Microsoft Windows browser protocol. So we have the Wireshark wiki. Let's see and understand this. Protocol dependencies, SMB typical. So looks like this particular Microsoft Windows browser protocol is actually playing a role in SMB. SMB is ultimately relying on this Microsoft Windows browser protocol. That's cool. And domain name system. Apart from SMB, I could see DNS as well, some DNS traffic. Okay, it's useful. Then the TCP. Let's come to the TCP traffic. In TCP, we could see some transport layer security, some encrypted traffic, and here is the HTTP, Hypertext Transfer Protocol, and you can see some OCSP, Online Certificate Status Protocol, media type, line-based JavaScript object notation extension. Okay, so here is the data. So I think this section denotes the data that has been transferred over HTTP. All right. That makes sense. Now we need to focus on DNS and data, and we also got some SMB traffic. Just keep in mind. All right. Moving on to the Wireshark statistics. So let's see the conversations. All right. You can see the conversation here from layer 2, network layer. You could see the Ethernet, and it has some hardware address. And in IPv4, in layer 3 network layer, you could see some this one is data link layer, this one is a network layer. In network layer, you could see some IP addresses and other IP addresses, including some public IPs. Now, I guess it makes sense. You could see this traffic, the 10.4.7.17.101. It is common in every traffic. That means, so this is the IP of the local machine. Yeah, this is the IP of the local machine. If I check the name resolution, can I see the host name of the machine? It just resolves the, okay, it resolves actually, but when I jump to TCP, it fades. All right, awesome. Okay, so this is the I think it looks like name of the adapter, name of the network adapter, I guess. All right, move on. This is the IP address of the machine, the infected machine. And I could see this one 10.4.17.1.1, I mean 17.1, a potential gateway address to this IP. So the contact is happening, the communication to the external network is happening via this gateway. And you could see the number of packets to this IP, this particular IP. So we can sort this out based on the number of packets. And you could see a bunch of packets has been transferred between these two IP addresses, and some top IP addresses you could see here based on the number of packets. It's going to help us 142, 250, 115, and 95, 87, 249, 49, 206, and some other public IP. So the gateway is actually the fifth IP addresses. Before that, there were 4 other public IPs. Okay. Now, all right. What I'm gonna do, I'm gonna mark all these addresses, because maybe it's gonna help us to answer these questions. Copy. Can I copy this? All right, I'll type this. I think it is in the clipboard. Awesome. Now, no, it is not in the clipboard. Copy. Come on. Can I copy this to my clipboard? Yeah. Yes. I am just trying to note down all these. Most of the time, I mean, all these IP addresses that hit most of the times. It is not always necessary that these IPs could be malicious, but it's a good practice to note down the top IPs for investigation. This particular IP, there were 77 and 14 packets respectively in each direction. Okay, note down till this. Hmm. Instead, how about taking a screenshot of it? Can I paste it here? Cannot paste it on Sublime Text. Okay. All right, we will note it down. I move on. And here, if you see the TCP traffic, most likely the HTTP traffic. Let me filter based on number of packets. And here I could see the IP addresses which I already noted down. Yeah. And you could see the port detail here. HTTP, port 80. The remaining traffic 443. But our focus is 80 for now, because we know it's a malware traffic. So there are high chances that it was happened through this port. 87, both 87 and 85 it starts with. So these two IP addresses to focus on. All right. And how about UDP? UDP, we clearly see most of the traffics are the DNS traffic. and some multicast traffic. So I know this is actually the multicast IP address. So it is used by every device in the network to identify, to recognize the fellow devices on the network. Okay. Now, I guess it gives us some insight. I'm moving on. I'm going to go and close this to get into the main window of Wireshark. Here, actually, excuse me, I have I came across an option for the name resolution. Yeah, here it is. Resolve network address as well. And now you can see the network address is also resolved into the domain name. And now if I go to statistics, conversations, and now if I go to name resolution, look at this. It clearly gives us the domain names, right? And look at this. First one, googleapis.com. And the second one, krd6.com, which is quite weird because the remaining names, if you see, it looks legitimate. Belongs to Microsoft, Google, some traffic manager. I'm not positive what traffic it is, but the KRD6 stands unique, right? If I just uncheck this, yeah, the traffic with 2032 packets, 703 from A to B, from victim machine to the domain, and in return from domain to the victim machine 1329 packets. All right, so let's see what is this KRD6 domain is all about. I just opened virustotal.com, and now I can use this particular domain name to search. I can search this domain name in the VirusTotal, krd6.com. If it is malicious, then so this is the culprit. Yes, look at this. Now we could see clearly that this one is actually belongs to a malware. But for now, we just move on. I'll load down this domain name, krd6.com. 6.com. Yep. And now I close this window, get back to Wireshark, statistics, and endpoints, and this one again the same, right? Yeah, the same stuff. And let's go to the conversations. Okay, both are nearly same. Packet lengths. Okay, this is just gives the size of the packet, the packet's length wise, how many packets in how many in how much length. All right, I guess now it looks cool. Now what I'm going to do, let me filter out the DNS traffic alone, because okay, first I'll do the SMB traffic, because in the protocol hierarchy I've seen SMB. So let's see, and also the number of packets were quite less. There were only 3 packets in SMB, and I could see that here. So let's see what exactly happened here before I'm moving into DNS and HTTP. Come on, let me go. Local master announcement, desktop FWQ3U4C, workstation server NT. Come on, what it says. SMB mail slot protocol, mail slot name, mail slot browse windows. Okay, look at this one. The host name, desktop hyphen FWQ3U4C. Looks like the host name of the machine, right? Yeah, looks like the host name of the machine. Let me go and copy this value. Can I see the answer of the host name? I guess it should be correct. Did they ask the host name here? No, but the IP address they ask, because we already seen like um, every traffic that or I mean, what is the IP address the original suspicious traffic come from? Looks like this is the IP, right? 10.4.17.101, because that's the machine. That is us. The traffic began from us. But we will confirm that in a moment. But before that, looks like this one is just an SMB. I go and follow the UDP stream. Yeah. Protocol browser. A protocol browser in Wireshark. So let's search and understand what is. Yeah, Wireshark wiki. As I said, yeah, this is the browser protocol, and SMB relies on it. Typically, browser uses SMB as its transport protocol. I think browser is relying on SMB. So here SMB is the transport protocol. So what's the purpose of it? Wireshark dissector, fully functional, partial functionality. Okay, preference settings, example capture file. Display filter is browser. You cannot directly filter the browser protocols while capturing external links. Okay. Well, what's the purpose of this browser? Purpose of protocol browser in Wireshark. Let's see some Gemini outcome. The browser protocol in Wireshark is used to analyze network traffic related to the Microsoft Windows Browser Service, which helps the discovery of network resources and services. Typically uses SMB protocol. All right, looks like some path access. I'm not sure. Maybe like this: mail slot /browse. I think they might have tried accessing a UNC path, which eventually used this SMB to access some remote share. I think that's what happened here. All right. What about the 12th stream? Because the browser protocol is actually the UDP stream number 13. If I go to 14, do I see anything? SSDP. Not going to be useful to us. Come on. How many streams do we have totally? 21. How about 30? We don't have 30th stream. 25, no. 24, no. 22, yes. 23, yes. So totally 23 UDP streams. All right. So we are going to find it one by one. For now, I just put the filter DNS to see all the DNS traffic, and let's see follow through UDP stream. So this particular stream is stream number 12, and I could see the domain name krd6.com. I think it tried to resolve the domain krd6. I can see this clearly here, and you can see the traffic originated from our victim machine ourselves, 10.4.17.101. That's the infected machine, and it reaches gateway, eventually the DNS, to get the response of this domain. Response of the IP address for this domain name, and here is the response, and it responded as 87.249.49.206, which is actually here in our list of IPs. All right. Looks like we got the answer. So it tried to resolve this krd6.com domain. Let's go and answer the questions one by one. What IP address is the original suspicious traffic comes from? So it actually began from 10.4.17 101. So let me copy this IP, copy value. All right, that's the answer. And the attacker downloaded a suspicious file. What is the HTTP method used to retrieve the properties of this file? So we need to triage more to answer that. It appears that this file is okay. So this is all about the file that has been downloaded via HTTP. Now, what is the domain name that malware is trying to connect with? We already know the answer for it. So it's nothing but the, let's see the name resolution, krd6.com, right? krd6.com, and that's the domain name. And what's the IP address that the attacker has constantly used for communication? Is it going to be this one? I guess. And I'm also seeing the other domain solution, but okay, we will come to that part. But before that, let's see. So this is the IP address for the domain name krd6.com. For now, this is fine. Move to the next one. I have no answer to these questions. What program is used to execute? What is the host name of the compromised machine? Yeah, we know this. The host name of the compromised machine is, we've already seen that in SMB, right? Yeah, here it is. And the name of the workstation is this one, desktop FWQ3U4C. And what's the key that was used in the attack? What is the OS version of the compromised machine? What is the owner of the compromised machine? After decrypting the communication from the malware, what command is revealed to be sent to the seed server? All right. Okay, we so far answered just 3 questions. We need to answer the remaining questions. But for that, we're going to find the file that has been downloaded from this C2 server. So in order to find that, let's go and check out the HTTP traffic, because that is what we have to check, right? Yes. And look at this. Look at this one. So the HTTP traffic is completely about accessing the domain that we spoke about. I'm going to leave these ones because this is just OCSP, the Certificate Status Protocol. I think these protocols are necessary for the TLS communication before encrypting your web traffic. But for now, you can see here is the traffic. So this is the first traffic to the domain krd6.com, the HTTP traffic. It happened to the packet number you can see. And this is the response. Yeah. The first, it checks for options. It checks the list of available HTTP methods. Then it gets the response. So let's see the HTTP stream here. And you can see options. So it sent the list of allowed options. Options, head, get, profile. So this is the C2 server actually. And the C2 server, the IP address, the domain name is krd6.com, and the IP address is 87.249.49.206. So this is the IP address from where I think the malware gets downloaded, right? Okay, let's see. So this is the stream that reveals the options traffic. I just take this and just re-add the HTTP filter. And if you see the next one, next HTTP stream, I could follow this. You can see it actually access the path, the endpoint share. Again, with options HTTP method, it again gives the list of allowed methods in this particular endpoint. Okay, so this is the stream number 32. I guess we can check the next stream. Can I go just from here? Nope. If I just put this one, so this is the next HTTP stream, and this stream is actually having a new method, and you could see that here. So this one is the SYN-SYNAC ACK, the TCP three-way handshake, and then it accesses the prop find share, the TCP session established, and it actually tried to access this share endpoint with this method, prop find. I guess we are answering another question at this point, which is nothing but, let's see the method. The attacker, yeah, this one. The attacker downloaded a suspicious file. What is the HTTP method used to retrieve the properties of the file? I guess it is prop find. So to confirm that, let me go and follow this HTTP stream, and you could see the status here. So this one is actually brought the XML content. Looks like a metadata of a file, right? So looks like the prop find is the answer to this question. All right. And then what else? Moving to the next one, maybe 34, the next stream. Again, it accesses this. I go and follow this HTTP stream. The same stuff. 35, how about 35? And it accesses a file called desktop.ini. Can I go and follow this HTTP stream? Yeah. And look at this. So this is the content of the file, I guess. Yep. Or maybe the metadata, I don't know. Maybe I'll move on. I'll see the next stream. Look at this one. Here is the highly suspicious file called avp.msi. An MSI file is actually a kind of an executable exe file on Windows, but it is not exactly same, but it is still kind of an executable. MSI file, a Windows installer file, software installer file, package used for installing, updating, or removing software on a Windows operating system. It contains all necessary information and instruction for the installation process, making it a standardized format for software deployment. Okay, so looks like an installer is against us. What's the file name? And we found a file name, which is nothing but avp.msi. avp.msi, and that's the file name. Awesome. Moving on, what is the SSDP hash of the malware as reported by VirusTotal? But how to find the hash of the file at this point? Which is quite simple. We need to extract the particular MSI file from this packet capture. So let me show you how to do that. But before that, let me see the next stream. Once again, the same stuff. Moving on, 38. Again, it is trying to access the metadata of the file. Yeah, metadata of the MSI file. 39 stream, and look at this. This one is actually a bulk stream. Potentially, this is the stream that downloaded the MSI file. If I keep my, okay, I think at least I can follow the TCP stream to see the same response. Yes. And look at this. Now we could see the clear get HTTP method against the endpoint share avp.msi. At this point, my infected machine downloads avp.msi, the malware, the malicious installer. We're going to confirm if it is a malware quite soon. But before that, let's scroll down and see how this file looks like. It looks like it's a binary. Of course, this is how it would look like. And instead, I'm showing it as ASCII. If I just try to show it as a hex dump, I would eventually be able to see the magic bytes of the file. Let me show you. Just by seeing the hex data of any file, you will be able to identify what sort of file it is. So for that, you need to check the file magic bytes list of file signatures. We knew it's an MSI file, and let me see what's the magic byte for this MSI file. And here is the MSI format, and it starts with D0CF11. And yeah, it exactly starts here. D0CF11, E0A1, B1, 1A, E1. Yes. So this is where the MSI file starts. This is just the HTTP response header. So followed by the content of the MSI file. All right. Now we found how to dump this, because I mean, maybe we can use one thing. We can just save this particular stream as a file to extract the MSI file. Otherwise, it is possible to extract that particular file without um, tampering it, maybe by using an option called export objects on Wireshark. So if I go here to SMB, I don't see any file exchange over SMB. But if you go and see HTTP, I could see the bunch of files were exchanged via HTTP. Out of these files, I could see the file avp.msi, and I could see a bunch of XMLs. All these XMLs are just the metadata of the file, but what we are interested in is this one. The content type is x-msi and the file name is avp.msi, and also the file size is quite huge, which is 1427 bytes. So which is 1427 kilobytes. So which is what required. So I'm going to save this file in my directory, and now the file, the malware, the alleged malware is on the disk, and you could see the avp.msi. If I just apply file against this, it clearly says it's composite document file, which is MSI, the MSI installed. So this is actually potentially a malware. So let's confirm that. Maybe we can use hash to identify whether it's a malware. And this is the SHA-256 hash of this file. And I'm going to VirusTotal once again. Just search for the file hash. When I search, I could clearly see 40 vendors out of 62 have been flagging this as malware. So it clearly says this is a malware, and let's see whether we're able to answer. We'll be able to answer few of the questions, because we were seeing some VirusTotal reference. We are in the VirusTotal page, the malware page. Now let's see whether we are able to answer some of the questions. What's the SSD hash of the malware as reported by VirusTotal? Is it possible to find an SSD hash here from here? Sudo apt. Is there any utility to find the SSD hash? Search for SSD. Do I have a utility? Piecewise hashing tool. How about this? How about downloading this SSD? Okay, let's do that. Install. All right. Now I have this SSD utility. -H to see the help menu. Can just pass the file against it, avp.msi, and looks like we got the hash. I guess it is possible to find the hash in VirusTotal as well. Let's see the detail section, and yes, and look at this. Is it matching? 24576 BQKXN. Yes, it matches. So this is the SSD hash of the malware. So, all right, I'm gonna go and copy this and put it here. And now, according to the Nike Analytics community comment on VirusTotal, to which family does the malware belong? Let's do some OSINT here. I go to community, and they were talking about this Nike Analytics, right? And what was the question? To which family does the malware belong to? And it's pretty clear that this family is SS load. Yeah, so this should be the answer. And what's the creation time of the malware? Gosh, how do we find that? Uh, when I use, I mean, let me use a stat against it. If I use stat, everything says current date, but I don't want it. But I want the exact date when the malware is generated. And look at this. In the details section, it also holds the file creation time. And it is pretty clear that it was created long back. It was created in 2009. So let me go and copy this. This must be the answer. Then what's the name of the domain? We already found that. And what's the IP address that the attacker has constantly used for communication? But before that, we should know, I mean, are they referring the command and control or the IP address from where the malware was downloaded? If they are referring the IP address from where malware was downloaded, then the answer should be 87249. Otherwise, if they are pointing out the malware traffic, then it must be something else. Let's find that out. Okay, next question is, which file included the original package? Including the original package is extracted utilized by the malware during execution. Which file included the original package and is extracted and utilized during malware execution? I could see a bunch of names here, but look at this. Which file is extracted and utilized by the malware during execution? I think they are referring this zip file, avp.msi.zip. So this must be the answer. I'm not positive. Just putting the answer here. What program is used to execute the malware? Again, we will be able to find the answer from this VirusTotal page. Let's find out. Behavior. Do I see anything, any interesting info? Looks like the network communication triggered by the malware. 85.239.53.219. And what is that? Yeah, this IP address. It is already spotted in the Wireshark. So it has to be this one. More likely. Now, if I go and see the DNS resolution, I could see the domain name. Looks like the domain name. Okay. Now I want to find which program used to execute this MSI file. I'm just trying to spot them. Let's see. See the list of processes created. If I scroll down, mutex is opened. I think mutex is a term in the advanced malware analysis. I'm not sure about the mutex part, but I'm trying to learn them. So once I have a clear idea, I'll explain it maybe on the another stream. MSI execute. So these are all the mutexes created. But I don't want that mutex stuff. Instead, I want to know the list of processes created so that I can find the program name that used to execute this. Do I see anything in the community? Come on. So here is the report. While it is opening, can I see the family is SS load? And you could find the sample from Triage. Triage is actually a website to download the malwares. And here is the Joe Sandbox analysis. And look at this. Looks like this api.ipi5.org is the C2 domain. Once the malware executed, it tries to communicate to this domain. And here are the IP addresses. I already noted down this 85 IP. Do I see this 104 IP anyway? I don't see it in my list, but maybe I might have overlooked it. Doesn't matter. Let me move on to the next stream now. But before that, can I see which program used to execute this binary? I'm just trying to find that stuff. Let's see. MSC exec.exe initiated network connection over HTTP. I guess they have used a utility called a Windows legitimate utility called the MSI exec to execute this MSI installer. Come on. May I see the relations once again? Can I see any process called MSI exec? Behavior. Moving on. MSI exec. Process and service actions. And look at this. MSI exec utility has been triggered from system32 path. A legitimate binary it is. So the utility should be MSI exec.exe. So this is what triggered this MSI file, I guess. Let me put it here. And what is the key that was used in this attack? What is the OS version, owner name of the compromised machine? After decrypting the communication from the malware, what command is revealed to be sent to the C2 server? Now we need to uncover the command and control communication, right? Let's move on. I go to the next stream because the command and control is also on HTTP, I guess. Because when I was searching for, remember this is 40th stream. Now, if I go to DNS record, I could see there was an attempt to resolve this domain name, api.ipi5.org, and it gave the response. The response you can see here. 104.26.13.205. This is the response, the resolved address. Now let me copy this IP address. Come on. Can I copy this somehow? Answers, yes. I got the IP address, I guess. 104.26. I think I was seeing the IP address is it communicated to, right? And look at this 104.26.12.205.443 and 85.239 80 53.219 on 80, and again 172.67.74 152 on 443. So these are the IP addresses that it tried communicating, and I'm seeing exactly the same. There are three IP addresses: 104.26.13, 104.26.12, and 172.16.74 152. So looks like we got three IP addresses. Out of these three, to which IP addresses the HTTP communication was made? Let's find that out. I go to statistics again, conversations, TCP, name resolution. Come on, why I'm not seeing it? All right, I have the filter in place. And in the conversation, TCP, can I see the, come on, can I see the IP address from this 172.67.74 152? Do I see it? Okay, I have another idea. Just go for this page and put the filter. I don't see any traffic to this IP, which means this is not the IP address of C2. How about this? I don't see it again. And how about another one? Look at this. Now I could see the encrypted communication, encrypted HTTPS communication to C2. So this is the C2 communication. I'm damn sure this is the C2 communication, and I'm gonna go and follow this TCP stream, and I can't understand anything because it is TLS traffic. But change cipher spec. What is? Follow TLS stream. Come on. I don't see anything. Follow TCP stream. Do I see anything? I don't see anything. But this is the C2 traffic, I'm pretty sure. If I go to 40th stream, so this is where the communication to the krd6.com is happening. From this domain only the malware got downloaded. But when I move to the next one, again it is the same communication, 42 the same communication. But what about following the HTTP stream? Come on, 43, the TCP stream. How about this following the TCP stream? I don't understand anything because it's encrypted. 44, look at this. Again, a HTTP stream. I follow this TCP stream, and now I can clearly see the communication to this IP address 85.239.53.219. Do you remember this IP? I mentioned this could be the IP address to C2. So that is what happened here. So this is the IP address of C2, I guess. And you could see it's actually posting some data to this IP address to this endpoint, API gateway. So it clearly says this is the C2 address, and I'm not seeing it on the virus total, but yeah, here it is. So this is it, 85.239.53.219 and on port 80. So this is actually the address of C2. Yeah, this is the address of C2, and for the encrypted communication it uses this one. That's okay, but before encrypting the traffic, I think it uses port 80 before encrypting the C2 communication. And you could see that here. What it does, it actually collects some information about the host and post it to this endpoint, API gateway, to this IP address. And now the response, you can see it actually sends the key and some ID. The key is actually potentially the key to encrypt the traffic, right? I think that's what happens. And that's the response here. It's apparently the key. So this is the key. Like, what is the key that was used in the attack? And this is the key. You can clearly see. And then if I just see further, I could see the encrypted communication now. It says some ID, maybe the job ID. It's unique, and the job name. And here is the job. But as far as I understand, this is encrypted. Looks like a base 64. If I go to CyberChef, I don't know what is the encryption scheme used in this, but I got the key. Maybe if I find the encryption scheme, I'll be able to uncover it. I already have the key in place, right? But for now, I'm just moving on. A GET request to download endpoint with ID Nevada, module 2 file name none. It says internal server error. So what happens here? It is posting some data about the machine to this endpoint. In the response, it sends the key. Now they actually put the task ID here and just accessing the endpoint called tasks. And now it is sending them the task to be executed, the job to be executed. Since the infected machine already has the key, now it is receiving the encrypted data. And now what happens? Again, you can see the job ID here, B98. It starts with, ends with 546. So this is some sort of job, but when they try to execute this job, I guess it is not happening. You can see the response here. Last time, I think when they accessed this endpoint, it triggered the internal server error. Server got itself into the trouble. Followed by the task execution. It says okay, but nothing other than that. I don't see anything else here. But what I can say is I got some version number here and an IP address. I don't know what it is, but the domain is workgroup, workstation name. The host name is given here. Architecture, OS version. I guess this is one of the questions, the OS version. And what is the owner of the compromised machine? And the owner is Nevada. After decrypting the communication from malware, what command is revealed to be sent to the C2 server? Still, I have not uncovered this, but when I was looking this virus total, I found in community section, I found this particular comment. You can see it is noteworthy to highlight a malware sends the following command to the C2 server, and which is nothing but this one. So looks like this is the answer to the question. So it is telling it to download. We have seen this request, right? Yeah. So here is the job. So once it received the job, yeah, look at this. I guess it just executed the job. And the job, once it executed, it actually threw the internal server error. Now it makes sense. So this is the job. The machine decoded the job and it sent it like this. Download, and you can see the IP address here. So by using this, they've crafted the whole command: http://885.239.53.219, and the endpoint is download ID Nevada module 2 file name none. Yes. So this is the command, and you can see the command. This is exe, which is sent by the malware. Okay, this is actually sent to the malware from the C2, and once it decrypted, it executed this command simply. Then I think it tries sharing the outcomes. Yeah. Okay, now I guess we have answer to this. Since I've already answered all these questions, let's verify this. 10.4.17.101 is the answer to the IP address. Yeah, this is our IP address. And the prop find is actually the method to retrieve the properties of the file, and the avp.msi is the right answer, and the SSDP hash is correct, obviously, and the SS load is the family, and creation time of the malware was 11:47:44 for December 11th, 2009. That's good. And the domain name that the malware trying to connect with is api.ipi.ip5.org, which is not KRD6. KRD6 is actually the supplier that supplied the malware to the machine, but it was actually api.ipi5.org. We already see the domain name 5.org. All right. Then the IP address attacked constantly for the communication, it was 85.239, 53.219. Yeah. And what file included in the original package is extracted and utilized by the malware during execution? I was wrong. It was not zip. Let me go to this details, maybe the details, relations. Can I see the file? And here it is, force del ctl.dll. So this is the DLL file associated with it. Yeah, this is the associated DLL file. I was wrong. Then what program is used to execute the malware? msexec.exe. What is the host name of the compromised machine? I was right. The key that was used in the attack, I already got that. Task 13, OS version. And what is the owner of the name compromised the machine? Nevada. And here is the command revealed to be sent to the C2 server. Sent by the C2 server, I guess. They might be wrong here. All right. So this is what this challenge is all about. We've solved this Sherlock. It was an easy challenge. But let's go here and see the write-up. Did I leave anything behind? They actually grabbed the hash. I think I should improve the methodology, the way that I work on a forensic investigation. I should be doing it. Maybe I should be capturing some hashes before I'm starting the investigation. The artifacts provided, and the skills learned, network traffic analysis and threat intel. Yeah. Some endpoint statistics. Yes. The same approach as we did. What's the IP address of the original IP address? Looking through http.exports, we can see some files downloaded. Come on. Yeah. The same as we did. So they did the same stuff. They followed the HTTP stream and found the communication of the malware. Attack downloaded a suspicious file, and the profind is the method, and you can see that here. Yeah, it appears that this file is a malware. What's the file name? avp.msi is the file name. Yeah, it's an installer package, and in the virus total, you can confirm it's malicious. Yes, it is. The SSD hash, they retrieved it. It's a program for computing text triggered piecewise hashes, also called fuzzy hashes. CTPH can match inputs that have homologies. Such inputs have sequential identification. I don't understand. I really have no idea what is SSD. But we found the answer anyway. Again, a virus total, threat intel, and the family label in the detection tab. This is load. And the creation time of the malware, we got it from virus total once again, api.ip5.org. So this is the connected domain. What's the IP address that the attacker has constantly used for this communication, and which is here. All right, I think they just took the same approach as us. Which file included in the original package extracted and utilized by malware during execution? I was wrong here. I overlooked it. I should have looked this dropped files, but I thought it is the zip file, but it was not. It was talking about, it was all about the DLL, the library. All right. Using 7z to check contents of avp.msi provides confirmation that this was included in the original package. Come on. I think to check the components of avp.msi provides confirmation of the, since we already knew avp.msi is an installer which contains multiple files within that. It's an installer that supports installation of the program. So it actually a file that with every essential files, combined. I think it encloses all the required files. So I should have done this. Maybe let me learn this now. Maybe I'll do this 7z -help. Just wish to see what is this yell is all about. Let's see. Capital L or small l. List contents of the archive. Yeah, I think I should have done this. L avp.msi. avp.msi itself is archive. So I was confused with zip. I was wrong. And now I can see the first elctl.dll. And this is the file. So this is the main file I was trying to install via this avp.msi. Yes, maybe I'll go and take a screenshot of it. I need these to store. I'll store it in my notes. I already have my notes open, and I'll include it in my notes. If I knew this 7z extraction, I didn't think the MSI is actually an archive. So I used virus total to check the DLL file and tried it. But this is the actual way. Used 7z L to list the content of the archives. All right. Moving on. What next? Yeah, it's the name and the The program used to execute the malware. Activity summary. Is that what mentioned there? Activity summary. Can I see that? Yeah, here it is. I'll take a screenshot of it. Copy to clipboard and put it on my notes. All right, moving on to the write-up. And what's the host name of the compromised machine? And we've seen that from the C2 traffic, and also in that browser, the SMB protocol traffic. Okay, the key, we found that Windows version, Nevada. After decrypting communication of the malware, what is the command revealed to be sent to the C2 server? The question is quite difficult if the player attempts to reverse the malware on their own. However, with the little research, the blog article such as following show that the C2 communication encrypted with RC4. And here is the encryption scheme, which was RC4. RC4 was the encryption scheme. And here is the blog that talks about this malware. RC4, yes. The encryption scheme was used is RC4. Come on, not this one. I use a different tool to copy this. Okay, come on, where is the link? Can I copy the link? Yeah, and yes, unraveling the SS load multi-stage malware. I'm just noting down this thing, but since we got the encrypted data now, let me go and decrypt this with RC4 decryption. Can I see RC4? Yeah. And I need the passphrase, right? Which is nothing but the key. And if I use, come on, if I use the key, it's not human readable. Output format is UTF-8. Yeah. Error 16, maybe base 64. Yeah. Can I try to decrypt this from base 64? Come on. I don't see it. I was wrong. Now I could see it clearly. The input format is base 64 and the output format was also base 64, but I just disable this and put it in Latin 1, which clearly gives me the decrypted phrase. And now I can see the decrypted content of this blob. Now I'll go and add the screenshot here. Maybe I mention it as C2 decryption. Actually, when I was solving this challenge, I didn't know what was the encryption scheme. Maybe I should have done some open source intelligence. SS deep malware. If I search SS deep malware, do I see any blog mentioning it? Uh, does it have the encryption scheme? Maybe I'll go to Google and search it. Yeah. RC4. Can I see it on this page? RC4. No. No. This is in the blog. So fuzzy Android malware. Maybe. Let me copy this hash value. Website was netwitness.com, but I don't see that in this list. Okay. Yeah, this is how we uncover the C2 traffic. All right, this is how I managed to solve this challenge.